So, dear 10th class students, now we are starting the new chapter, progressions. Here we are going to define two terms, sequence. First, sequence. Sequence means a list of numbers put in a definite order is known as a sequence, ascending order or descending order. Order means, what I mean to say order means ascending order or descending order. The list of numbers put in an order is known as a sequence. For example, 1, 10, 18, 23, 67, 75, 100, etc., etc. So this is a list of numbers put in an order, ascending order, like this. This is about sequence. Understood? Now, progression. A sequence of numbers in which each term is generated by a rule, a specific rule is known as progression. Here there is no rule for these numbers, but if the terms are generated by a rule, specific rule, then that sequence is called progression. I think you understood the sensitive difference between sequence and progression. Sequence is just the list of numbers kept in an order. No rule, okay, it has to obey. But in progression, the sequence of numbers in which each term is generated by a specific rule is known as a progression. So, a sequence of numbers in which each term is generated by a specific rule is known as a progression. Now let us take an example for progression so that you will understand more clearly. Okay? Before going to example, I would like to introduce you a notation. Please take that notation. Notation. See, the rule, okay, using which you are generating the terms of a progression, the rule using which you are generating the terms of the progression is known as the general term, and it is denoted by AN throughout this chapter. So, the rule using which the terms are generated, the terms of progression are generated is known as general term, and throughout this chapter it is denoted by AN. Please do understand. A suffix n. So the rule using which you are generating the terms of a progression is known as the general term, and it is denoted by an throughout this chapter. I think you understood. Okay. Now form a progression. An example now I am taking. Form a progression in which an is equal 1 by n into n plus 1. Okay. So we have to form a progression in which an is equal 1 by n into n plus 1. So now how you can form? You have to put n is equal 1, 2, 3 and so on, and you have to get the corresponding terms of the progression. Now you go for a1, 1 by 1 into 1 plus 1, 1 by 1 into 1, 1 plus 1 is 2, it is 2. a2, 1 by 2 into 2 plus 1, 1 by 2 into 3, which is 3 by 2. a3, 1 by 3 into 3 plus 1, 1 by 3 into 4, which is 4 by 3. Therefore, the progression is what? Required progression. Therefore, the required progression is first term is 2, second term is 3 by 2, third term is 4 by 3 and so on. Understood? Chalo. Now we are going to discuss about arithmetic progression. So our now point of discussion is arithmetic progression. So I am defining what is arithmetic progression. See, in a progression, except the first term, if each term is generated by adding a constant number to its predecessor means just immediately previous one. Predecessor means immediately previous one. So if each term is generated by adding a constant number to its predecessor, then that progression is called arithmetic progression. See, in a progression, I am not going to write, once again I will repeat, just listen. In a progression, except the first term, if each term is formed by adding a constant number to its predecessor, then so formed progression is known as arithmetic progression. So here I will give some examples for arithmetic progressions. Examples for arithmetic progressions. See, say take 2, okay, 6, 10, 14 and so on. Take this. This is clearly an arithmetic progression because except this first term, you see every term is formed by adding a constant number 4 to its predecessor. 6 is formed by adding 4 to its predecessor. 10 is formed by adding 4 to its predecessor, like this. So this is an arithmetic progression. And if you go for another example, say -5, okay, -7, -9, -11, this is also an arithmetic progression because here the constant term which is being added to generate each term is -2. the constant number which is being added to generate each of the term in this progression is minus 2. That is, minus 2 is constant, you see. So this is also an arithmetic progression. So like this you can give so many examples for arithmetic progression. Now you are coming to the point. The constant number which is being added is called common difference. The constant number which is being added to the predecessor to get a term of AP is known as common difference, and it is denoted by D. Okay, and the first term is usually denoted by A. So now, considering first term as A and the common difference as D, now let us write the arithmetic progression in its general form. So general form of an arithmetic progression in which first term is A and the common difference is D. So as the first term is A, it is A. The common difference is D. So how you get second term? By adding common difference to the predecessor. So you have to add D to predecessor. So you get A plus D. How you get third term? Same. You have to add D to its predecessor. So if you have to add D for A plus D, then you get A plus 2D and A plus 3D and so on. It goes like this. So if you observe here, no D's are there in first term, 0 D's. In second term, 1 D is there. In third term, 2 D's. In fourth term, 3 D's. So what you are observing? Number of D's is 1 less than the number of the term. So how you can write the general term? N minus 1 into D. 1 D will be lesser than the number of the term. Now I am writing nth term. So in nth term, there will be n minus 1 D's. So the nth term of any arithmetic progression is A plus n minus 1 into D. Therefore, in an AP, nth term is A plus n minus 1 into D. Understood? So, dear students, now we are solving some important examples. Okay, the first question is find the number of terms. Find the number of terms of the AP. Find the number of terms of the AP 2, 6, 9, 12 and so on, 1, 1, 1, 111. So how many terms are there in this AP that we need to find? So as a part of solution, first collect A value and collect D value. How do you get D? By subtracting first term from second term, or by subtracting second term from third term, like this. So just I am doing A2 minus A1, second term minus first term, which is 6 minus 2, which is 4. So D is equal to 4. So now in order to get the number of terms, you have to depend on the last term. So let AN be equal to 1, 1, 1. What is AN of AP? A plus n minus 1 into D. Just now we have discussed. It is 1, 1, 1. What is A value? 2 plus n minus 1 into, what is D value? 4. This is 1, 1, 1. So n minus 1 into 4 is equal to 1, 1, 1 minus 2. Are you following? So excuse me. So in this progression, the first term is wrongly printed in the textbook. So this, because the first term is wrongly printed, so this is a wrong question. Okay, so this is a wrong question, forget about this. Now the correct question is, find the number of terms of the AP 3, 6, 9, 12 and so on, 1, 1, 1. So first you see, is this AP or not? See, clearly this AP, because the first term is 3 and the common difference you see 3, 3, 3 you see everywhere, right? So here A is equal to 3 and D is equal second term minus first term, A2 minus A1, which is equal to 6 minus 3, which is 3. So D is equal to 3, A is equal to 3. Now to get the number of terms, okay, you have to take this as AN. The last term consider as AN. AN is 111. So AN means A plus N minus 1 into D equal to 311. So what is A3? 3 plus N minus 1 into D is also 3 is equal to 311. So N minus 1 into 3 is equal to 311 minus 3 by transposition. So N minus 1 into 3. So if you subtract 3 from 311, you get 108. Then N minus 1 is equal 108 by 3. So N minus 1 is equal 3 3s are 3 6s are. Okay. So then N is equal 36 plus 1. So N is equal 37. So you got N is equal to 37. So therefore the 37th term would be 111 in this arithmetic progression. Understood?